Okay, hey everybody, welcome back to day 7 of summer school geometry. In this module, we're going to be talking about similar figures and how we can apply proportions in the context of similar figures. If you notice, these two shapes look like they're the same shape, but they're different dimensions, meaning this one is clearly smaller than the bigger one over here, but if you look closely at these angles inside of here, they are the same as the angles of this shape over here. If I were to measure the length of AB, whatever that length is, AB, if I divide it by the length of GH, I have this fraction here. So I could put numbers in place of here, in place of AB and GH. If I figure out what this fraction is, that fraction should be equal to the other fractions that I can set up with using the other sides of this four-sided shape here. Now I'm going to look at the top BC and HI. So I can set up another proportion BC over HI. And I can keep going all the way around the shape. So CD over IJ. And the bottom is going to be JG over DA. These fractions right here would all be equivalent to the same value. They could all be simplified down to the same value. So for example, let's say AB over GH was 2 over 4. Then all of these other fractions would have to be equivalent to 2 over 4. So I could have 3 over 6, or 5 over 10, or 1 over 2. All these are equivalent to each other. They're all equal to 1/2. They can be simplified down to 1/2. And whatever that value is, all of these equal 0.5 or 1/2. That's what we call a scale factor. So let's look at a few examples here that'll be similar to your assignment that you'll see after this video. So we have given Q and QRST with these little marks, these apostrophes next to them. Those indicate the smaller shape over here. And then we have is a dilation. Now a dilation means you're making an object larger or smaller, you're enlarging it or making it smaller. And then QRST is this regular shape right here with just QRS and T, no apostrophes. Find the scale factor of dilation, which meaning how did I get from this shape over to this shape? What did I do to the number 14 to get to 6.3? Now, whenever we have a scale factor, you have to think about the operation multiplication. Because if I want to make something, make a shape larger or smaller, I have to multiply the number by something. And so now I need to think about what did I multiply. So the general rule here that you can use to figure this out is whatever side is given to you. So we have 6.3 and 14. And if I'm getting from RS to R prime S prime, if I'm going in this direction, then I'm going to put R prime S prime in the numerator, and I'm going to put RS in the denominator. Just like at the top here, we set up these fractions. I'm going to set up a fraction here. So I'm going to put 6.3 in the numerator and 14 in the denominator. And let's go ahead and do 6.3 divided by 14. This is Desmos that I'm using here, so I got 0.45. Equals 0.45, and that's what we call a scale factor. All right, now let's talk about this next problem here. It says given the right triangle ABC, so this large one is ABC, it has altitude BD. Altitude is the height of the triangle going in this direction. And it's drawn to the hypotenuse AC. So AC is the hypotenuse down here. It says if AD is 4 and DC is 9, what is the length of BD? Okay, so what we need to understand here is I have a total of, if you were to count how many triangles you see here, this is kind of an illusion type of thing. There's actually 3 right triangles in this image. There's the very large right triangle, the largest, most right triangle. It has a right angle up here. Then you have this small right triangle right here. And then you also have this other medium-sized right triangle. And this is also a right angle right in here. So that's a total of 3 triangles that are all kind of merged together in this picture. Now, the way we approach this is if all of the triangles are drawn within each other, like the largest one has the smaller and the medium one within it, then those 3 triangles are similar to each other. We can set up those fractions, those proportions. So what I'm going to do here is I'm going to trace the largest triangle in red. Okay. And what I'm now going to do is I'm going to rotate that out and move the triangle out here so you can see it kind of clearly, like this. All right, so there's the red triangle. I'm also going to draw this blue triangle here, and its right angle is right there. And I'm going to rotate it right here, just like this. And I'm also going to do the same thing. I'm going to move it out this way. Okay, so now you can kind of see all 3 triangles in the same way. Let me go ahead and label the corners of each triangle. Our goal initially was to figure out what was BD. So let me take the dimensions also. On my medium-sized triangle, a 9 for the tall side. For my small-sized triangle, I'm not going to put a 4 here. The 4 was actually AD. The 4 goes down here like that. And then X was the tall side of the small triangle. So X goes here. And at the same time, X was also the short side of the medium triangle. Okay, so in this type of a problem, you only need 2 of the triangles. Our goal here is to figure out what is the length of BD. So in this case, we don't really need this red triangle. So I'm going to get rid of it. I'm going to erase it so it doesn't get in the way. Now let's just focus on these 2 triangles here. And let's go ahead and we're going to match up the sides just like this. So I'm going to use X over, this X goes over this 4 right here. These 2 guys. And I'm also going to match up these 2 guys. So I did X over 4, the bigger triangle and the smaller triangle after that. Bigger triangle, smaller triangle. So 9 over X here equals 9 over X. And now what we want to do is we want to solve this proportion. It's actually an equation now. And the way we can solve this is by doing something called cross multiplication. So cross multiplication is I multiply diagonally like that. So I get over here, X times X is X squared. And 9 times 4 is equal to 36. That's going to be X equals 6 because 6 squared is equal to 36. So that means that X is equal to 6, or you could say that segment BD is equal to 6. And there you go. That's the side of that length right there. You can go to Canvas now and look for your assignment for today. If you have any questions, please do email me. Here's my email. If you have any questions at any point or need help with something, let me know. Shoot me an email.